Hello, welcome to another interesting episode number 9 on coordinate geometry 1, the straight line. In this episode, we are taking the second aspect of division of a given line segment into a given ratio. And in this, we are picking the external section or external division of a line. Now, let's pick the line segment AB. Our line segment AB is a line segment we have. But this line segment has been divided externally, meaning they've given us a ratio from A to P. They have extended a line. Then they've given us a ratio from A to B. So A to B is given, then A to P will be given. That is, the line is extended 4 centimeters. If the line is extended 4 centimeters and the distance between A and B is 2, then it means from here to here will be 2 plus 4, making 6. So A to P will be given as 6. Here will be 4, here will be 2. That's external division. So if the line segment AB is what we are dealing with, then we can say that the coordinate will be x1, y1, the first coordinate. Then the second coordinate will be x2, y2, because that's the line given to us before it is extended. So you want to find the coordinate of this, it will be x, y, what we are asked to find. All right. Now let's indicate some other letters. Let's say A, B, C. So let's put Q and R here. This is 90, that is 90. So this give us 2 right angle triangle. I can see a bigger right angle triangle ARP, a smaller one BQP. That's 2 right angle triangle we are having here. They are similar. One is extended to form the other. So we can say the ratio of their corresponding size will be the same. Alright. Now what are we going to do? We can say that by that assertion, if I pick the line segment, let's say we are labeling here as M, labeling here as N. Don't forget, if you take all the way, we can be given that. We can also say from A to C is M. Then from here to here will be M minus N. Let's take it that way. C is an external division, okay? So all the way to P will be given as M. Then from the small extension is N. Therefore, here will be the longer side minus the extension will give us here. Alright, so let's go. I'm picking the first right angle triangle. ARP. The longest side here will be, let me see, ratios. I'll be having AP divided by the smaller right angle triangle here. We'll have the side BP, which is slant. It will be the same as AR divided by the shorter side BQ. That could also be the same as if I pick the vertical one, which will be PR. I am referring to the longer right angle triangle. Then the smaller one will be PQ. That will be the same as the longer side M, shorter one N. That will give rise to our first equation. So from this equation, we can find the coordinate of the various sides. So let me pick the first one on the horizontal stretch. AR, BQ. So let me find A and R. So the length of AR will be on the horizontal stretch, picking here as the X highest value, picking here as the X smallest value. So the highest value minus that. So let's see if we can pick the coordinate. This coordinate on the x-axis, what value on the x-axis do we have? We have that one to be x. This is the first one here. Then on the y-axis, what number will be there? y1. Let me take it again. The point here, if this is extended to have your x, the point that will be here will be the value we use to extend the p. That will be x value. On the y-axis, we have y1. That will be for r, the coordinate of r. Then for that of q, I am still going to plot the point here on the x-axis first. That will be x. Then on the y-axis, what point is here? y2. So here will be y2. So let's take that into consideration. If that is out of the way, then the x value here minus the x value here. What is the x value here? X minus x1. So I have x minus x1 as equation 2, representing AR, horizontal. What about BQ? BQ, horizontal. That will also be BQ. I am going to still have on the x-axis greatest point minus smallest one. Greatest point will be x, smallest one will be x2. So x minus x2. X is here, x2 is there. That gives us equation 3. So now putting equation 1, 2, and 3 together, picking just this side and this, I'll be having AR to be x minus x1, BQ to be x minus x2. That should be the same as m divided by n. I guess we can do that, right? All right. Let's cross multiply. So n will be multiplying the numerator here, x minus 1 equals to m. We'll also multiply the denominator x minus what? x2. I guess we can do that. So now let's expand to have n x minus n x1 mx, if this also multiply mx2. What are we looking for? Actually, we are looking for the x coordinate, which is the p, the x. X, we will be giving this and that. So let's group like terms. Having the nx, this is coming as minus mx. This is going to be minus. But if I take this one, then it become plus nx1 minus mx2. You see that it maintains a negative stature. This is going to be negative, transferred to become positive. So minus, as we have it there. X, group the like terms. What are we going to have? We can have x into bracket. What will happen here? We have n minus m equals to n x1 m x2. But I can see x being isolated only if I divide by the coefficient here. So n minus m. N minus what? M. It will cancel to give you x equals to, we are having n x minus x1 m x2 divided by n minus what? M. So we can have this as the x coordinate. Now, from the first one we did, which was the internal, we are always beginning to bring in first the m before the n. If we are doing so, I can push in this one here to become negative m. This will be plus n. But if I introduce a bracket like this will become negative. This will become what? Negative. So I have to indicate here to be negative. First, I am only changing their position, right? I'm changing the position of them. This is positive n, negative m. But if I introduce a bracket, then this negative will have effect with the positive m to become negative. Effect with the positive n to become what? Negative. I can do so. Similarly, I can do the same. The negative will come forward, this will come in. So when I see negative in the numerator, negative in the denominator, they will both cancel, leaving us with only m x2 minus n x1 over m minus n. So we can get this. If you want to follow the internal division, bringing the m coordinate first before the n. This is the same as that. You will get the same value if you were to operate it without this. This is not there. If you are to operate it like this, with that, you get the same answer. But to have a generalized formula to mirror that of the internal division, we can go for this as the x coordinate. We are going to go, right? Good. For the y coordinate, we are going to be dealing with the horizontal axis. So let's pick PR first. The length of PR going to be, the PR will be on the y axis, right? This. So this is your y1, y2, y itself. This is the y is there. y2 is here and y1. I am taking PR. The greatest point will be y. So y minus smallest point, y minus y1. Equation, I think we have equation 3, so let's go to equation 4. All right. Then we are dealing with the shorter version, PQ, just from here to here, greatest minus the smallest one. That will be PQ will be y minus y2, equation 5. So now we combine equation 1, equation 4, 5 together in this small corner to give us y minus y1, y minus y2, the same as m over n. The same concept we did for the x will be replicated here. So I'll go straight forward with the multiplication. This will multiply to give you ny minus ny1 if you multiply. Then m will also multiply this, my minus my2. So fast forward, let's group like them to maintain the y, which is this and this. So n minus, y minus my equals to this guy going in first to become positive ny1, then minus my2. Right? We can find our y as factorized n minus m, ny1, my2 divided by the coefficient n minus m. Your y will be equal to that. Remember what we did for the x coordinate. We can bring in m y2 minus n y1 m minus 1. So that gives us the y coordinate for the point that is extended, the external division. So let's put that together as a generalized formula. We can have the coordinate of the point xy to be equals to x coordinate to be m x2 minus n y1 m minus n, comma y2 y1. Good. So that becomes the formula for finding the external division when a line is divided into a given ratio. Externally, this is the formula. The only difference is the minus sign. Internal, we use positive sign. Internal, we use positive sign. Then external division, we use the negative sign. I'm sure you get the concept. Good. The next episode, we will take questions that we can use to explain the concept. Don't miss that. Like, share, and comment. Bye-bye.